Ari.
Yes, sir, it is clear.
Okay,
Audible, sir,
okay.
please start.
Good morning, everyone. This is Ravindra Paliwal, Workshop Superintendent from Anjuman College of Engineering and Technology. All my dear participants, students, all invited guests, our expert speaker for today's session, Dr. Nilesh Ingle, sir, Dr. S.M. Ali, Principal Anjuman.
Hello.
Today's morning here is very pleasant. It is raining out here, overcast sky with dark clouds. Adding to the beauty is the lush green surroundings. Friends, Anjuman College of Engineering and Technology is a provider of university level education, UG, PG, and PhD in engineering, and is affiliated to Rashtrasant Tukaroji Maharaj Nagpur University. We are centrally located in the heart of Nagpur city. We are a dynamic, fast growing educational institution fully responsive to the local and regional needs and are aware of our contribution not only to the university level education but to the social and economic development of our region. Students of our college are afforded a high quality education with state of the art resources. Our college was founded in 1999 and in its 2 decades of standing, it has earned a well deserved reputation in central India as a pioneer and a niche institution. We recognize and are proud of the fact that our college campus is centrally located in southern area, one of the cream areas of Nagpur, easily accessible to all students where commuting is a non-issue for all. We have with us today Dr. Nilesh Ingle sir, an eminent data sciences person with a rich academic and professional background who will give us an insight on prospects of data science and artificial intelligence for mechanical engineers. Ingle sir is a biomedical engineer with experience in data analytics, design and prototyping of medical devices and biotechnology encompassing areas such as gene therapy, tissue engineering, biomechanics and medical textiles. His key strengths include data sciences, wherein he has command over SQL, R Studio, statistics, and predictive modeling. His skills comprise of mechanical testing polymers and tissues, chemical and biological testing, microscopy, cell culture, and so on. In software, he is comfortable with MS Office, Hygens, Emeris, ANSYS, SolidWorks, Flash, JMP statistical software, ImageJ. He has a number of accomplishments under his fold, including 17 published journal articles, one book chapter, 9 conference proceedings, 5 honors and awards, and 9 conference presentations. He is a specialist of textile technology, biomedical engineering, fiber and polymer science, medical devices, surgical sutures, bidirectional barbed sutures, cardiovascular biomaterials, biomedical textiles, statistical analysis, design control processes, wound care devices, disposable medical devices, and so on. He has a rich experience as integrated data specialist, as data analyst with Game Circus, as associate data scientist with Biofair Diagnostics LLC, as consultant with Biomedical Consulting, and as development engineers with Medtronic. He has done his graduation BTech in Textiles Engineering and MTech in Textiles Engineering from VJTI Mumbai in the year 1999. He did his dual degree, Masters along with PhD, in 2009 from North Carolina State University, Raleigh, NC, USA, in Biomedical Engineering and Fiber and Polymer Sciences. From 2009 to 2015, He continued with his biotechnology research at Virginia Technology, Blacksburg, VA, USA, and University of Minnesota, Minneapolis, MN, USA. From 2016 to date, he is working in the field of data sciences. It is my pleasure to invite Dr. Nilesh English sir to share his views on today's topic, which is prospects of data sciences and artificial intelligence for mechanical engineers. Sir, please, sir.
Sure.
English sir.
Thank you, Professor Paliwal, for the kind introduction. I'd like to begin by thanking Professor Ganorkar, Professor Fidvi, Dean Lange, and Professor Asim for organizing and inviting me for this talk. Uh, I'd also like to thank all the faculty, staff, and students at the university, at Anjuman College of Engineering and Technology in Nagpur for joining us, and all the audience that we have here today. So let's begin. The topic of today's presentation is prospects of data science and artificial intelligence for mechanical engineers. And the outline of this talk is going to be first, I'll go through what is data science and artificial intelligence, abbreviated as AI, and then we'll look into what is the relevance of mechanical engineers to data science and AI. Moving on, I'll show some data about the importance of data in the world today and how fast it is growing. Moving on, I have a couple of examples that relate artificial intelligence to mechanical engineering, and we'll go through some of those as well. And finally, I'll talk about how to get into data science. This could be some information that students or anybody who wants to get into data science could find it useful. So, what is data science or artificial intelligence? So, data science, based on my experience, is a combination of three different domains. First is programming, which is computer side of it. So, you have to know coding, algorithms. And then the second side is statistics, mathematics, and algebra. And in addition to this, you have this domain knowledge. So a combination of these three is data science. So the area that would be here in the center. So it's you probably realize that it's a multidisciplinary field. Now, if you are a mechanical engineer, then your mechanical engineering domain is really helpful to bring those skills into solving problems in the world of data science. So, for mechanical engineering, I would say you have the mechanics background. If you do not know coding, that's the part you'll probably have to add into your skill set, and you already have a strong mathematics background, so there you'll be comfortable with in the data science. Now, what is AI? Here I have a picture of John McCarthy. He's considered as a father of artificial intelligence, and according to him, the artificial intelligence is uh, science of making computer programs that are intelligent. So programs that can solve real world problems. And one of his quotes that I found early on was a mechanical engineer and designer, and he designed several mechanical arms. So he's referring to one of his graduate students who helped him design the mechanical components, hydraulics of a robotic arm that he was working on. So that was one of the first AI creations that he was working on at that time. So mechanical engineer is kind of core to robotics, as you probably already know. Now, from mechanical engineering, how it is relevant. So a mechanical engineer brings in skill sets. For example, they know mechanical design, and that needs a lot of creative thinking. So that's a skill set that mechanical engineers already have. The second is analytical thinking. So they are thorough in mathematics and mechanics. So that's another part they are very strong on. And then they have the domain knowledge, which is mechanical design, statistics, static dynamics, fluid dynamics, thermodynamics, mechatronics, and so on. So combining all these skill sets makes it a very attractive proposition to solve problems using data science tools, uh, which are related to maybe processes or manufacturing or production, or even in biotechnology. So here on this slide, I have a couple of examples. So let's say you are a mechanical engineer and you have now learned all the tools about what that can be used in data science. Then if with the skills in mechanical design, you could you could use those skills in generative design. We'll talk about that in a minute. If you have interest in electronics or electrical side of that, then in mechatronics you can work in the area of robotics and automation. Furthermore, if you are interested in the biology side of it, then you have experience, you can work in the biomechanics aspect of it. And in healthcare industry, you can design different types of medical devices. Similarly, if you are into ergonomics, so industrial safety could be one of the aspects where a mechanical engineer could contribute a lot. Then you have imaging. Imaging is a part of computer vision where you could be bring in your skills in quality control. And I have an example of that. We'll look at that in a moment. Moving on, these materials. So you have knowledge of materials. So you can use that knowledge to create new composite materials, or you can use that knowledge to create biomaterials, for example, mechanical characterization of these materials. Finally, if you are interested in getting into pure data analysis, then that's also possible because you have a strong quantitative background. And as a data in data analysis, you can help businesses make business decisions based on the data that they have. And finally, as you may already know this, in transportation, you can be really bring in your mechanical skill sets to aid in the development of self-driving vehicles. This could be self-driving cars, unmanned aerial vehicles, or this could be automated ships. So my thinking is that wherever there are parts involved that need to be automated and programmed, mechanical engineering knowledge is definitely a big help to the teams that are trying to work on those projects. And the catch here in this is I've put this circle outside which says learn. What I mean there is that if you are a mechanical engineer, then transitioning into data science uh, would be a step where you have to learn new skills. So you can pick any of these areas, and as you move into that, you'll have to learn. For example, if you get into mechatronics, you may have to learn electronics. To get into biomechanics, you'll have to learn a little bit of biology sides of cells, tissues, how they work, etc. So now let's look at why data is becoming so important in the world today. This is a chart that I found from an online source where we can see that from the year 2011 to 2020, let's say up to this year, 2020, we have big data revenue up to 55 billion worldwide. And in the next 7 years, is going to increase to almost 100 billion. So imagine that. So the investment of what that the companies are making in the world of data is going to double. What that would mean is that the products, that database products, would double or increase substantially. And so the people who are needed to work on these projects would also increase. Therefore, the skills in data science are going to increase. Demand for those skills is going to increase a lot. This is another plot that shows the growth in AI publications. So if you see on the y-axis, we have the percentage, which is percentage of papers in artificial intelligence based on all the research areas. And from the year 1998 till 2018, we can see that there is almost a threefold increase in the numbers that papers have been published in this area. So this is to tell that the research is in AI is increasing rapidly. And if you look at the distribution of research all over the world, you can see that the academic and corporate collaborations is increasing a lot. So here, as you can see, different shades of green. The darker the shades, the more number of academic and corporate collaborations are there. So you can see that there's a worldwide impact of AI and research in AI. And as a university and as a student, I think this is a great opportunity for academicians to work with the industry to develop new products. The questions that industry brings in, the academic teams can work together to kind of find ways to answer those questions using AI, data science. Here, this plot shows the different types of deep papers published in AI in the periods between 2015 and 2018. And here we can see that there are several countries actively working in this area. And in India also, we have published around 400 papers during this time. So, and the good point here is that there is a tremendous scope in AI research as well, and that we could be able to see in incoming 5 to 6 years in future. This map is a quid map, and the way this can be interpreted is here we can see there are different clusters of data. So each of these dots represent a company, and what this plot is trying to show is the investment activity worldwide between 2018 of July and July 2019. And these are about 4,403 companies that were analyzed in here. What we need to look here is that if the cluster is towards the center of the plot, it means at its core to the field of this investment activity. So more attention is given to that particular field, such as robotics. And then fields that are on the periphery, they are important, but they are a little less important as compared to those that are in center. And then the proximity between these two clusters tells the amount of interaction between those two fields. So let's get into this plot and see what we can find. So if we look at data center and data tools, it is right in the core of this particular plot, along with robotics. So for data center, if you are a mechanical engineer, you could work in this area. However, you may not be using your mechanical skills, but you'll definitely be using your analytical skills in working with data. Next, there is a field of text analytics. So one example that I found where mechanical engineers could be working in this area is there are design specifications that are used by design engineers to create different engineering drawings. And there seems to be area of where there is a difference in interpretation of the requirements from different functional teams. So AI is currently being researched to kind of automate that process, so the design engineer knows exactly what needs to be modeled. For example, a house could be called a house, it could be called apartment, it could be called a building, but you can combine all those two and derive one meaning that it's a living space. So that's kind of the example of that. In robotics, as you probably already know, mechanics can be used because you'll have different mechanical parts. You know how the sensors work on the instruments, and those need to be coded into computer program to work seamlessly. In sports and games, engineers can design new types of customized devices. For example, you could design shoe for runners that is customized for that particular running style. So that would involve analysis of the mechanical forces as the runner puts the step down, and how the shoe can cushion those forces to make it comfortable for runner to run. Then in games, there is a debate if you could work, but if you
Even our
have a
PPT,
mechanical background.
we cannot see your PPT screen.
Oh, you can't.
No, sir.
Oh,
Your PPT is not visible on the screen.
can can you see it now?
दिख रहा है क्या अभी? No, sir. No, sir.
uh,
कैसे
oh,
करेंगे?
so let me try.
You have to maximize your PPT on your screen and then share it. Just try maximizing your PPT
Okay,
and then share it.
okay, let me try that.
अभी आ रहा है क्या? यहाँ अलग से आएगा. क्या करना फिर?
Can you see my screen?
Now it is visible, sir. Now I can see it.
Okay,
This is okay. This is okay. Thank you. Thank you.
okay,
Please carry on.
sure. So the next, so we talked about data center, we talked about text analytics, we talked about robotics, and then we talked about sports and games. Next, let's look at medical imaging. In medical imaging as well, uh, mechanical engineers can definitely be helpful in analyzing images. For example, if it's an image of fractures, then the mechanical engineers could help understand the mechanics behind how the fracture might have taken place. In drone and unmanned aerial vehicles, there are different avenues where you can design the flight system of the drones, and that can be programmed into the computer. Moreover, you have AR and VR. So you have augmented reality, virtual reality applications where you can work on the physics side of those programs. Then you have different examples of industries. You have oil and gas industry, agriculture, you have medtech, you have energy management. So in all these fields, there is a lot of processes involved, a lot of sensors, and that's where you can definitely contribute and work on different aspects of solving problems. Finally, autonomous vehicles. That is, you probably heard about Tesla, and there are several other car companies that are working on this. So in this particular case, again, computer vision is one area which is really taking up. And in this, designing the sensors and kind of connecting the mechanical sensors to the actual computer, that's teamwork between computer programmers. And if you are a mechanical engineer or electronics engineer, you would be able to help understand the data that's coming in from the sensors. In legal tech, that's seems like an outlier, but it's where mechanical engineers or any engineer can get into work. The way that would work is either you could be analyzing different patterns and finding if those patterns are different or same than existing patterns. And then secondly, on the new side, there are new applications that are being developed that are trying to automate this process. So if you are working on an area which is devoted to mechanics, then that would be helpful here as well. Finally, in marketing and ad technology, this would not require your mechanical skills, but then you would definitely use your analytical skills to find answers to which particular product is more marketable than other and things like that. Now, let's get into brief examples of how mechanical engineering is related to AI. So you're probably aware of this process of turning where you have this aluminum rod and that needs to be reduced in size to a specific size using this tool. And as this is rotating, this cuts into that particular aluminum rod. Now, I've found this paper where on the left hand side we have this figure where what they have done is they have integrated computer vision into this cutting process. So as you can see, this cutting process is connected to an adaptive observer, which what the adaptive observer does is it takes readings from the sensors and processes it to adjust the location position of the cutting tool. And if you add computer vision to it, what by taking pictures of the tool itself to measure the wear on the tool, combining these two, they were able to see on the graph on the right hand side that they are able to monitor the position of the tool accurately. So in this graph, the X mark shows the microscope measurements, and the X graph with the circle shows computer vision calibrations, and the line shows the estimated tool wear. So as the time goes on the x-axis, on the y-axis, you can see that uh, the estimated tool wear is pretty much very close to what the microscope measurement is trying to show. Next, let's look at one example of AI in quality controls. On left-hand side, we see a figure where a person is inspecting tire, and the tire is kept on this instrument, a machine, which does the task of rotating the tire, and a person has to manually look at each tire, touch it, and inspect it to see if it is faulty, if it is defective, or if it is not defective. And what they've tried to do here is use AI to kind of automate this process. On the figure on here, what you can see is the first step in that is taking picture of the tire, which is shown here in the red, and then these are the steps of AI, which is convolution, max pooling, convolution, and fully connected layer. If you do not understand it right now, that's perfectly okay. The gist here is that that's the AI part of the programming, and what it does is it takes each picture, and if you look at it, the way computer sees its picture is just a matrix of numbers, and as shown here in the grid, each of these numbers is processed to give a final output to say if the tire is defective or if it is not defective. And so what as shown in this figure, they have created this circuit, or they are working on this, where you have this processor logic control, which is the PSC inspection stand, and the human machine input. So that's where the programmer or the user could type the input, and it was relate to the inspection stand. That is, PLC kind of finds, it has the sensors, and it takes the sensing data to CPU or GPU, which is the computer part of it, and then it is processed by the DCNN, which is the AI part of it, deep convolutional neural network, and then it is relayed back to possibly to the HMI to tell if the tire was defective or not. So that's very quick explanation of one use of AI in quality control, where mechanical engineers can be helpful because they would understand the mechanics of the rubber, how it works, and if there are cracks or defects in the rubber, they'll be able to point out why they are. Now let's look at another more recent development in the field of engineering drawing. You probably already know about this. Here we have a picture of a bracket, and from the left to right, you can see that the shape of the bracket has changed, and that is by way of generative design. What it does is it uses AI to minimize, to find the optimal shape and weight of the particular product or any other requirements that you feed into the program. So you get a very lightweight product based on what you have originally, and it performs equally well. This is one example where it has already been put in practice by Airbus, where on the left-hand side figure, you can see that there is a bionic partition that they've created, it is 30% lighter than the original partition. And you can see that here in the pink color. And what they claim is that 1 kg of material removed from that plane can save 106 kg of jet fuel per year. So that's a lot of carbon footprint you're removing from the atmosphere. And on the right side, there is a conceptual drawing where they have plans to design the interior of the aeroplane using this generative design, which would be like a grid, as you can see in this particular picture. Now, what generative design can do is it can give you thousands of designs. On the left hand side, this is a plot that shows that is a weight versus stress on the y-axis. And here we can see there are different designs. And based on these designs, the red color is showing kind of the stress levels. And on the y-axis, we have the weight. So you can choose what weight you would like the panel to be and what weight it should, what stress levels it should survive. And on the right hand side, you can see a picture of comparison of this image of finite element analysis image of your door panel, which is original panel. And on the right side, you have the panel, which is the bionic panel using generative design. And you can see that they perform pretty good, similar, I would say, and that's kind of exciting to see. Here, let me show you a video where this is computer generating different designs, as you can see, and it will finally do a stress analysis. And after the stress analysis is done, you have the final product or final design that can be put into actual fabrication process. So this is the design that they have used. In this particular video, you can see that each dot represents a design, and you can change different parameters very easily in this software Autodesk to create these types of designs. And you can change the force, you can change the stress, you can change displacement, you can change the weight of that, and you can look at the output and kind of find designs that meet your design specifications. And once you have narrowed down to the design specifications that you are interested in, then you can use that for your final prototyping of that particular design. Here you have, let's say, shortlisted these designs that can be then analyzed for the application you have. Now, the way the 3D printing, based on what I could find, was you have the final design, which is a crude design that you'll have from the design engineer that that is then used by generative design algorithm to create a final design, and that design is then ready for 3D printing. So there are two methods that I've seen. One is selective laser sintering and or selective laser melting. So sintering would fuse the molecules together, but the temperature of the metal powder does not go up to its melting point, whereas in melting, it will reach the melting point. And here you can see this would be the 3D prototype part. And once you have this part, you can combine them as shown in the figure in the middle by these bolts, as you can see, and you can get the final structure as you can see on the right hand side. Now, this is a figure that I'd like to show, which has scanning electron microscopy images. On the left hand side, this is for alloy of aluminum powder that is also used in rapid prototyping. Maybe not for this bionic part that Airbus is making, but just to show you how the powder looks. So these are about 50 microns inside. So that's about the thickness of human hair. And on the right hand side, you can see the close up of that particular particle of that metal. And if you look through the cross section of that, you can see different features in it. So if you are a mechanical person, if you have knowledge of materials, then you'd be able to kind of look at this and tell if it's a good quality of material or not, what processes need to be changed to get a particular type of material. so that it has robust properties in the final application. Now let's look at actual rapid prototyping of that particular part which we saw earlier. And here, this is a video from Airbus, and here we can see that this shining part, that's the laser that is working through this bed of powder. So gray color is powder. And let me go back and show 1 second. Sorry. Oh, hold on 1 second. Uh, okay. Sorry about that. Okay. So what I wanted to show here is that here what happens is you have this bed of metal powder, and there is a mechanism that puts the powder over this, and then the next layer is printed again on this, then the powder goes over it, and the next layer is printed again over this one. So this is kind of the iterative process, and finally you have this product which is a final 3D prototype product that can be used for making the final structure. And this is really encouraging, and if you are a mechanical engineer, this is kind of a new tool for you to come up with new designs to that can be used in real world. This is another example which tells that it's not just restricted to small products. It can be used for making buildings as well. On the left we see a figure of a wireframe which was made by generative design, and on the right side we see a picture which is the actual building after construction. Now I did this one example here where AI can be used for identifying mechanical parts in a car. And here we have these pictures of a front engine part of the car, and on the right hand side we have the rear wheel, and you have the bolts in the seat. So the project was to identify bolts in the car. And as you can see in this video, what I've done is taken pictures of each of these bolts that you see in the car. I don't know if you can see them. It could be bolts or hex nuts. And here the objective was to use those to train the AI to identify these bolts. And you can imagine the applications of this. It could be used in a robotic assembly, which needs to either remove bolts or add fasteners to a particular mechanical part. So this could be a very one simple step that the machine has to perform that can be automated using AI. So you can see there are bolts near the front hinges, and there are bolts near the engine. You have this front panel, and there are bolts again here on this right hand side. So I've taken around 200 images, as you can see some of them here, and then processed them to teach the AI to identify bolts. And you can see here in the results that it was able to successfully identify the bolts, which is, you can see them by the squares on this particular image. And the number 92 is kind of the confidence which the computer thinks that it is a bolt and not something else. And in addition to this is really exciting, given that this was only 200 images. In real world applications, if you go in the industry, this processing is done on thousands or millions of images to get a final workable product, and that requires lots of computational resources. So given that this is a small data set, I think this is pretty good. On the left hand side, you can see there is one false positive. It thinks that it's a bolt. It's actually a rubber cap, but that's kind of expected there. Again, on this picture on the rear wheel, you can see that the AI was actually able to identify the bolts in this entire figure. And again, extending that idea from car, on such a small data set, you could also identify bolts on other parts as well. So here is a picture of railway track, and you can see that the bolts were identified by AI. And you have this another picture from pipes in oil refinery. Here it didn't identify all of them, but it's encouraging to see that with such a small training, it was able to identify at least some of them, that those are bolts. So as a mechanical engineer, think about the application. If you are working in a petroleum refinery, then you could be part of a team that is working on AI projects, where your insight on knowledge in hydraulics or petroleum, where the pressures inside the pipe, how they work, how much torque needs to be there on those bolts, all that knowledge could be used in making the AI workable. Finally, let's look at a biotechnology application, which is flow cytometry. What a flow cytometer is shown in this video. Here you have these cells, and what the cells need to be analyzed, they are put in this solution in this tube as shown on here, and that tube is then fed into the machine that's shown on the left hand side. The right hand side on screen, what we see is the scatter plot, which is the actual detected signal from the flow cytometer. So once the cells are a tube is attached here, the machine pulls the cells, and here it is passed through this laser, and the top conical part is where the cells are coming down, and there are two fluid flows through it. So if you are in mechanics, you know that this is a fluid dynamic problem, and using fluid dynamics, then you can, if you understand how the fluid flow works, you can help design these microfluidic devices. And here, as you can see, when each cell passes through the laser, there is a fluorescent label on each cell, and that signal is captured by the sensors, as you see on the other two circular signals. And these captured signals are then processed to detect what type of a cell it is. So here, based on the size, so if this is the cell and you can see the scatter of the light, it creates a different illumination on the sensor, and that optical sensor sends that data to a computer for further analysis. Now, the analysis is based on the voltage, and as you can see, based on the size of the cell, you can see the voltage changes, and you get this spectrogram which tells what type of cell it is. Now, why we are talking about that? Because there is a new technology called deep cytometry, which can do the same thing without the use of fluorescent labeling. So this is cell label-free analysis of the cells. And if you are in diagnostic, if you want to find if a particular disease or a particular microorganism is affecting a patient, you can take the blood sample of that and process it through instruments such as this one to detect if there is that particular microbe in that particular system of that patient. And the figure on the right hand side shows a similar concept, where you have these fluids that come into this area which is the microfluidics part, and there is a technology called time stretch imaging. What that is you have this dotted line, which is the actual laser signal generated after the laser hits a cell, and you have this green signal, which is attenuated signal, and that signal is directly analyzed by the AI in the computer, and it can tell if what type of a cell it is. And therefore, in this project, they were able to identify these cells which are different, which have different polarities, as shown up here. Now, moving on, how it is relevant to mechanical engineering, and you can see that fluid mechanics is what plays an important role here. So an engineer can design microfluidic devices using CAD. So we have done that, and then those devices can be fabricated in a nanofabrication facility and then brought into the lab to kind of put them into use. and you'll have to learn how signal processing works, and together you can help build some of these devices. So that's one example in biotechnology. There are other avenues as well. So if you are getting into data science, and if you think that you are comfortable using only your quantitative knowledge in mechanics, and you do not want to you do not have to have the mechanics part involved in it, then there are these applications as well. You could These are definitions from Wikipedia, but I think that there is quite a bit of overlap in all these roles. So, for example, if you are a data engineer, you would be uh, in a position where you'll take the data that's coming in from either live field or clients and putting it in a format that can be used for oncoming teams. These could be data analysts or data scientists. And what a data consultant can do is, if you are specializing in mechanical engineering, you could be put on a team that works on sites such as petroleum refinery or manufacturing facility, where you can look at their manufacturing data or process control data and tell how that can be used to find answers to the business questions that they may have. Then you also have data architect and application scientist. So application scientists, they usually I've seen do is, they would let's say if you are mechanical engineer hired as an application scientist, you would go into a kind of after sales process, where the instrument or the system is working at a client's site, and you go there, and with your input in mechanics, you can troubleshoot the problems or help the team understand how it works, and kind of help them assimilate that technology. So, in data analysis, if you're wondering what a data analyst does all day, what they do is they go through lots of data, and they kind of try to find answers to questions. One example here is, let's say there is a grocery store as shown here. You could try to answer business questions such as finding reasons why the customers are not satisfied, or find optimal product placements in the store. So if there are kids, they are looking for, say, chocolates, then usually they are placed on the lower aisle of the grocery store, so that kids can see them and they can ask their parents that they need the chocolate. So they would that would increase the sale of chocolate in that store. You could look at buying trends for regular customers. Do they shop on weekends or they shop on weekdays? And also find other factors that could increase sales of the products in the store. You can also predict what products need to be kept in the store for incoming season. Let's say if there is a festival coming in 3 months, you could stock up on all the supplies ahead of time, so that when the festival season comes, you have sufficient stock to give the products to your customer. So, how, after all this talk, how you're probably wondering, how does one get into data science or AI? And let's look at this plot here. What this is telling is the usage of different languages or programming frameworks in 2019. And you can see that the line on the top is TensorFlow. So that's seems to be one of the most commonly used languages, at least from the data from GitHub. And so you definitely want to be learning that language. Now, if you remove that language, there are other important languages as well. So let's look at those. Here, as you can see, the top we have scikit-learn, which is basically library in Python. And then you have Caffe and Keras, which is wrapper on TensorFlow. So you definitely want to learn some of these languages. You have PyTorch, so that has gained popularity. So if you are trying to get into data science, or if you are trying to get into AI, then you definitely want to think about how you can manage time to learn these languages. So to summarize, If you are a mechanical engineer, I'd say you have very strong foundation in engineering drawing. You have understanding of materials, composites, mechanics, and you have rigorous training in mathematics. Some of you, if you have specialized in mechatronics, you have knowledge of electronics as well. And of course, you have coded in finite element software such as ANSYS. Then all you have to do is learn coding, and coding could be languages such as Python, R, which is mostly used for statistical programming, Tensor, Keras, SQL, and there could be others, but I'll probably start with these. And then if you not already have knowledge of statistics, I'd suggest you probably should start learning about statistics, hypothesis testing, which kind of tells if a particular, let's say if you have uh, uh, weight, if you have a production line where you are making uh, different types of bolts, and if you're trying to find whether the weight of the bolt in one morning shift is the same as in the evening shift, then there you would use hypothesis testing and design of experiments to run an experiment to check if statistically there is a difference or there is not a difference. Then you have distributions where it kind of tells the shape of data, and you have descriptive statistics, which tells you the commonly used terms, which is mean, mode, median, as to how that can be uh, used to explain data. Then you have to have some understanding of variance. What variance is how much fluctuation is there in a data. Let's say if you are measuring weight of a bolt that is manufactured, then you can, if you plot that on a histogram, you can see variation in that. So if there is this variation, then you can, as a scientist, you can try to find ways to explain why that variation is coming and reduce that. Then you have to know understanding of probability, because most of the algorithms are based on probability. So the next note that I have for either fresher students or graduating students or students that have already graduated and already in the industry is, if to move into data science, I suggest searching jobs not only by the degree but also by the skill set. For example, if you search by Python and TensorFlow, you'll get several jobs. But then if you add mechanical to that words, you may not find any jobs listed. So I'd suggest searching jobs by skill set. And I've listed some of them here that I tried to search online, and did find some listings yesterday. And here I'd like to share this perspective of interdisciplinary jobs for the future. Moving on in the future, in next 10, 20 years, I think there is going to be a lot of interdisciplinary projects within the industry, and core jobs may may be reducing, or they can stay the same, whereas these interdisciplinary jobs will increase in number. And these are some screenshots that I've taken which tell the importance of interdisciplinary jobs. So the qualifications are BTech, electronics, electrical, mechanical. So they are not looking for just mechanical or just electronics. They are looking for an engineer who has analytical thinking, who can do this type of work. Then you have mechanical design experience. Then the next one, you have educational background in science, technology, engineering, mathematics, analytics, economics. So that's a very wide range of skill set. And even if you are in any of those, you are good for that particular job. And finally, I'd like to point your attention to the screenshot at the very bottom, which says you and us will work from our. So here they are asking for a mechanical engineer to join a new product development team in the medical domain. So you see how important is mechanical engineer in medical domain as well. So that's my message. So before heading off to the last slides, I want to express a word of caution, which is shown here in these plots. where on the left hand side you have the uh, AI adoption inhibitors, which are global, and AI adoption inhibitors that are specifically for India. And what I want to point out in these two plots is that one of the key drawbacks is lack of understanding of how AI models work and how applications make decisions. So, if you are learning something, I'd suggest learning the concepts, theory, and fundamentals of that one part thoroughly, so that you have a clear understanding of how it works. So when you go in the industry and try to implement that particular code or algorithm, you know why it is working or why it is not working. Because let me tell you, in industry, the real world data is completely different. It can be nothing like what we see when we study in courses or books. So having a thorough knowledge definitely helps. On the left hand side, you can see that there is a lot of insufficient or unusable data, and that's part of it. You have to work with whatever data you have, and there are a lot of budget constraints, such as the company will not allow you to use that much hardware or cloud space to run your simulations, because there is a cost associated with it, and because you cannot be 100% sure that that particular experiment would directly translate into workable product. So there is trial and error there as well. So there are these factors you could think about as well. So finally, these are the tips. You need to learn to write a code. Then you need to understand the theory and concepts, because it will help you in long run. If you get started and if you do not know the theory and concepts, you'll go up to a certain level, and then after that you'll stop growing. If you want to grow in this technical area, then you definitely want to know the details of how it works. And you need to learn basics in statistics and probability. This will help, but if you are working on teams where there is no analysis involved, where you are just working on the data preparation part, then this may not be applicable. But if you are working on the analysis side, then this would definitely help. And probably want to be open to learning concepts from new disciplines. So for example, if there is if you have a colleague that says in electronics that said, oh, we designed this particular circuit and it has this output, you should be curious to kind of know what circuit is that person is talking about and what output they're trying to get, and if my mechanical engineering background can help that person, or if I can apply that knowledge in my mechanical engineering background to solve any type of problem. And then searching jobs by skill set, as we talked earlier. And if possible, as soon as you graduate, I'd suggest, if it's possible for you, you can start an entry level job, and then in the off hours you can work on programming and coding, and you can do that for about a year, and then you can move into the core data science jobs. Or you could, if you have not yet graduated, you can assign time to building this skill, so by the time you graduate you have this additional skill, so that can help you find the jobs. So that was it. That was all I had to share with you. I hope you enjoyed the talk and found at least something useful, and that's my contact email if you want to reach out to me. Thank you.
Learn data, sir. Any questions from participants? मेरा क्वेश्चन डालो उसमें। वो आपका
So I have this first question: what is AI neural network? So as I showed you on one of the slides, neural network is kind of, think of it as layers of AI processing. So if you have an input image, what each of those images is used inside the program, and weights are added to that particular image. So the importance of each of those parameters changes, and the more important parameters get a higher weight. So in the output, then the AI can select the ones with a higher output as the one that is kind of the classified object for that problem.
Next question. Next question.
The second question I have is, what is the difference between AI and machine learning? That's a really good question. So if you have initially, when you get started, AI and machine learning would be similar.
Oh,
Okay,
sir, but
because the languages would be similar, the programming would be similar, the problems that you would be tackling could be similar. But if you go into research or you dive deeper into that, then in the industry, AI, it could branch out into robotics, and machine learning could branch out into predictive modeling that can be used to kind of uh, predict new variables for a company based on the data sets that we have. So next question is, can we find life of orthopedic implant inside the human body using AI? That's a very good question as well. So here, this can be an involved topic. So the way an implant works in the body is that it has to protect itself from the environments within the body. So what the body does is, anything foreign inside it, it tries to attack it and remove it, because it's not used to seeing that near it. So to avoid that, the implants usually have coatings on them that tell the cells inside the body that this is a cell-friendly part and do not attack it. Now, what AI can do is, you can use imaging modalities to kind of look at the structure of that particular implant over time. You can now use ultrasound imaging, for example, and combine that with dead material properties of the data, and it could help answer some of the questions about the life of an implant. Or you can do that simulation in situ, in laboratory, in a beaker, where you have an easier problem to solve, and you can monitor the conditions of that implant and its surrounding by sensors more precisely. The next question is, how to take a whip out of students of mechanical engineering, that AI and ML is not a total package of CSE and its students. So what I understand by this is that AI and ML is not only, it's not only that the person who has computer science background can work in AI and ML, but other disciplines such as mechanical engineering can also work in this. So my answer to this is that if you go in the industry, what happens is, both these people with different skill set work together. The computer science people, they have very strong computer background, they can work in actual C programming, where that code is put into production, whereas mechanical engineers, they can use prototyping languages such as Python to create workable products that can be used by the other team to convert it into production ready product that can be put in the market. So yes, both the disciplines can work, and both have different skill sets. So mechanics is a knowledge which the mostly the computer science people may not have. So if you are put on a team which has to go to a production facility, and there they are showing you manufacturing instruments, and they are showing you controls which look at pressure sensors, then a mechanical engineer can definitely help the computer engineer understand what that data implies. Thank you.
next question. Baba.
What are the main challenges in applying AI to mechanical engineering systems? Uh, that's another good question. So there are several challenges, and it's not easy step to make anything automated. I think this is going to go in the next 10, 20 years. For mechanical engineering systems, you're probably familiar with robotics and automated self-driving cars. One example that I can give is, in a self-driving car, if you try to look at the simulations, the way we see the world is from our eyes is different than what a computer sees the world and interprets it through a camera. For example, if we have a car going on a road and there is a shadow of a tree on the road, then we know that it's a shadow on the tree. But for a computer, it cannot differentiate between a shadow or if it's a hole or a pothole in the on the road. So we have to write a special code that can tell that the variation is shared. If it's of this type, then it's not a pothole, it's a shade and you can pass through, so do not stop. And if there is a different shape or features associated with a pothole, then you have to program that separately so the car will stop. So that's one example I can give. What is the probability that AI is faster than human intelligence till 2050? That's my guess is as good as yours in this case. One thing that I can tell is humans have imaginations that the machines are right now lack. But what AI is good at, it's very fast at processing numbers. So if you give it a calculation, it will do those calculations very fast. So it probably depends on how you define intelligence, I guess. Will there be any impact of AI on employment provision or employment generation? That's kind of a tricky question to answer because yes, there will be impact to some extent. For example, the jobs that can be automated, and if the companies are able to uh, kind of pay the cost or have the funds to implement that system, then those jobs would be replaced. For example, if you go to a supermarket and there are these checkout counters where a person scans the label on a product and feeds it into computer to get your bill and you pay it by credit card, all that can be automated. So you can attach RFID tags on the products and you can pass through a sensor through a gate, just like a security check, and all your products in the cart can be automatically picked up by the sensor. It can be charged to a credit card. So there can be no need of the person for the at the counter or the counter itself. However, there will be cases where there is another example, for example, radiologists. Now you have AI programs that can analyze an X-ray image by AI, which is comparable, the accuracy is comparable to that of a seasoned radiologist. So would the radiologist jobs go away? I think it's difficult. What could happen is that they could use AI as an additional tool to kind of help augment their process of detection. The next question is how the connectivity 4G and 5G affects AI and ML projects. That's a practical question, and it's really good you brought this up, is because you need a strong internet connection if you are working on the cloud. Okay, so for that, the connection of 4G could be sufficient if you are just typing a code. But if you are transmitting huge amounts of data, or if you have live data that's coming in, then that may not be that may be insufficient. So for normal work where students are trying to learn code, and if they want to use online tools such as Google Colab, or if you want to, they upload files to GitHub, which are less than 4 MB or 10 MB or even up to 100 MB in a day, it should be fine, I guess. Is it important to learn AI for ML? So AI and ML kind of is used interchangeably because what the core in those two would be the programming languages. So let's say if you learn Python, so Python is used in machine learning and Python is used in some of the AI applications as well, and they could be the same libraries as well. So if you learn one language, you could work in either of those two areas. But depending on your interest, you can then specialize in only one of those two. Are degree course in data science necessary for working in industry? Is it possible to assert our skill through qualification certificates? That's again a very job oriented question. The answer is both yes and no. It depends whom you are talking with in the industry. The first, I'll say that if you have a degree course in data science, what you are actually doing is you're learning only data science for 4 years, 3 to 4 years. So definitely you'll have a thorough understanding or knowledge of all the tools that you have in data science. So that's a very big plus. Now, if you are from other discipline, such as mechanical engineering, you would not have that edge that a data science degree would have. But then what you would have is your domain expertise. Okay. So what you'll have to do then is learn at least preliminary skills to get into data science. And then over the years, you can build your skill set in data science. And if you are in industry without any of this, and if you have already graduated, or if you are taking another additional course as a graduate, that is perfectly okay. The only catch I would mention there is that any course you take, what you learn from that course is more important than the certificate. The certificate could be useful if the HR manager sees your resume and they'll say, okay, this person has done this course. But then equally important is a project. If you mention in your resume that you have done this project, then that is also important. So it depends on who you're talking with. But if you are doing a course, definitely you'll get guidance, and it will kind of accelerate your learning process if that's possible.
So, thank you, sir. We are done with the question answer sessions. Thank you, English sir, for your wonderful and motivating guidance and detailed explanation of application of data sciences and how mechanical engineers can get into it for a good career. Sir, I am very sure this will act as a beacon for our students and help them to take right career decisions. Thank you so very much. Thank you, sir. Now I
Thank you
request
all.
now I request Dr. Akash Langle sir to please share his views on today's session. Sir, Akash sir. क्या हो गया?
Good morning to all of you. Ingle, you have given a very nice session with a slideshow.
Thank you.
Though I think all the participants have very much joyful from your presentation, and they have got a very good knowledge of AI and machine learning with data science, how it will be helpful to the students also. So I thought that all the participants learn that how to connect with the machine learning and data science. So thank you once again that you have shared good knowledge to the students as well as participants. Thank you once again.
Thank you.
Being the part
Thank
of
you,
our
Thank you,
Akash
session.
sir.
sir. Finally, I will request Professor
Valuable,
Ganorkar
sir.
sir. Thank you, sir. Finally, I will request Professor Ganorkar sir to propose the formal vote of thanks. Ganorkar sir, please. ऑडियो नहीं आ रहा सर, ऑडियो नहीं आ रहा गनोरकर सर. गनोरकर सर, ऑडियो चालू करिए प्लीज. मैं बोल दूं क्या?
सर अभी आएगा सर. गनोरकर सर प्लीज.
हाँ, गनोरकर सर आ गया. प्लीज सर, कैरी ऑन, प्लीज कैरी ऑन. गनोरकर सर, please continue with your vote of thanks, please.
Call him otherwise.
क्या बोले?
Again the audio is off.
Hello.
हाँ, गनोरकर सर, please start.
Hello,
We can hear
am
you.
I audible?
Yes,
Yes,
yes.
sir. Yes, sir.
Yes.
Please carry on, sir. क्या हो रहा है यार? Ganorkar sir, please carry on.
Yeah, am I audible?
Yes, sir.
Yes, yeah.
Hello. Okay.
Yes, sir. Yes, sir. Yes, sir.
Respected eminent respected eminent speaker of this very informative webinar on data science and artificial intelligence, Dr. Nilesh Ingle sir, respected principal Dr. SM Ali sir, our head of the department Dr. Akash Langde sir, my colleagues of Anjuman College of Engineering and Technology, and dear participants. I, Atul Ganorkar, as the coordinator of this webinar, deemed it a great honor to propose a vote of thanks to all those who have helped us in working their webinar a great success. First of all, I would like to propose hearty thank you to our speaker, Dr. Nilesh Ingle, for gracing today's webinar.
Thank
We
you.
are very grateful that you spared us some of your valuable time in spite of your heavy busy schedule. Thank you, sir, for your very interesting and informative address in the field of data science and artificial intelligence, which nowadays is giving much importance in the field of engineering. Thank you, sir, once again for delivering such an excellent presentation and making this webinar interesting and thought-provoking. I would like to express our deep gratitude to our principal, Dr. SM Ali sir, for his encouragement. I would also like to thank our head of the department, Dr. Akash Langde sir, for his support and guidance. Thanking our enthusiastic participants and students who are even eager to learn and grow and have turned up in such a large numbers, not only of mechanical engineering field, but also from various other fields from all over the nation. Dear participants, thank you for your cooperation. I am happy to express my sincere thanks to Professor Huzaifa Fidwi, convener of this webinar, who has taken tireless effort looking into every technical aspects of smooth conduction of this webinar. I would like to thank coordinators of this webinar, Professor Ravindra Paliwal sir and Professor Mohammad Asim sir, for making this webinar a great success. Once again, thank you all.
Thank you. Thank you,
Thank you.
Ganorkar
Yes,
sir.
sir.
Thank you, sir. Thank you.
Okay.
Thank you very much.
So finally, sir, we are concluding. We are signing off. Thank you
Okay.
once again, sir. Thank you, Nilesh Ingle sir. So
Thank
you,
you all.
everybody.
Thank you very much,
Thank you
sir.
for having me.
Thank you.
Thank you.
Thank you. Thank you.